Hello everyone, today we're going to be talking about the water cycle, and basically what that means is water is, a chemical, and it can go through different stages just like any other chemical. It can be in a solid state, a liquid state, or a gas state, and as it changes states, it's going to absorb or release heat depending on the transition that's happening. So in a solid state, we have ice, and the molecules are very rigid and solid and locked into place. And then as the ice absorbs heat, it melts and turns into liquid water, and the molecules can move freely. And then again, as it absorbs more heat, turns into gas or water vapor. Now this is very important that all along here it's absorbing heat, because as water goes through the water cycle, it is, redistributing the heat and the energy that is in our ecosystem and in our environment as it melts and then evaporates. And then once it has evaporated and has become gas, then if it releases heat, then it's going to go back to water, and then again, if it releases more heat, it's going to move back to that ice or solid state. And as they go, when it's in ice state, has very little energy, and the molecules are still moving, but they're just vibrating in place, almost as if, it's just a little kid standing still shivering. And when they're in liquid state, the molecules are in a liquid state, they're just kind of wandering around and going from place to place. Not particularly quick, but not stuck in one spot. And then in the gas state, they're running around crazy like most little kids do all the time. Okay, so here again we have the highest energy. Changed colors on me. No, stop it. There we go, highest energy. And then over here we have the lowest. And in this case, the energy that is being discussed is heat. Okay, so our water cycle over here, we've got, the main parts that you hopefully learned about, in elementary school. We've got evaporation, condensation, and then precipitation. So evaporation is when this liquid water from the oceans or rivers, lakes, gains enough energy, absorbs enough energy, becomes a water vapor. As it becomes water vapor, it becomes less dense than the air around it, is more energy than the air around it, and so it rises, just like when we talked about those convection currents in other videos. So then it rises, as we talked about in the cloud video. As it rises, the temperature decreases to a point that then the surrounding air temperature decreases to a point where the energy that is in the water vapor is then released. The water vapor condenses, and we get all these clouds. In the meantime, the water vapor is just in the atmosphere. That's what humidity is. And then when there's enough water vapor that has condensed into the liquid form of a cloud, then we get precipitation. And that can be in a solid form of ice and snow or sleet or hail, or it can just be, regular rain. And so at that point, we're going to have, the runoff, the rivers that are going to eventually get into the ocean, or we're going to have quite a bit that actually seeps into the upper layers of the ground and is groundwater. And some of that then over here we have some storage, and some of that again flows right into the ocean. Okay, now in the process we have we have some springs coming up, we have plants that are using this water, we have flora and fauna, so other plants and animals that are using this, and then we give off water when we sweat, when we breathe, other processes. And so then that, when we sweat, the water from our sweat absorbs the heat from our body and evaporates as we dry off, and that's what cools us off. That's why we sweat. And so, it continues this cycle. And what this cycle does, when the water evaporates, with very, very, very few exceptions, when water evaporates, no matter what else has been in the water, no matter what it's really been contaminated with, no matter what it's been around, if it's been contaminated due to something in the land environment, or if it's just full of salt from being in the ocean, when it evaporates as just pure water, and then when it condenses, we have fresh water again in the clouds, and all the salt or contaminants are left behind. So the water cycle is always a source of fresh water for us. And then also, since we do have, God made water so versatile that it can fall as liquid rain and come down the streams and give us immediate water, or we have this nice storage system of the ice and the snow in higher elevations or in the winter, where the water can be saved. When we don't need it so much, when we don't need it to really, for the moderation of temperatures in the summer as much. We're not playing in the sprinkler or anything in January. It's just being stored. It's waiting for us to use it. And again, similarly with this groundwater, it's just there waiting to be used. So water is a very important part of the environment. The earth itself is made up of about 75% water. Our bodies are made up of about 70% water. So it's very important. Scientists, definitely most secular scientists, say that water is pretty much the main reason that there is life on Earth. And so it's very important that we have this way to refresh and renew and clean the water, and it happens automatically all the time. Even when it's not particularly sunny, or even if it's as long as it's above freezing, then we're still going to have evaporation. We're going to still have that water being separated out from any kind of contaminants, be it the dirt, the salt, or any toxins that humans or animals have put in. So we always have this way of cleaning the water and filtering it, and having this this purity that's always necessary.